Hey everyone, in this video we want to see what a function is in mathematics. A function is simply just like a machine which receives an input, does some operation on it, and gives us back a corresponding output. And what is really important in this definition is that this machine corresponds each input to exactly one output. Now let's see some examples. Consider that we have a machine that calculates the area of a square. The input of this machine would be the length of the square side, and the output would be a number which shows us the area. As you can see here, let's say that the input would be 3, the side of the square, then our machine will multiply this number by itself, which in this case it is 3 by 3, and then as an output it will give us back number 9. Let's have another example. Consider our machine is a microwave which heat up the food. The input is a slice of frozen pizza and the output would be 1 slice of hot pizza. So as you see, the machine just heat up the food and we are receiving exactly one output for one input that we are putting inside of the microwave. So an important point in the definition of the function in mathematics is that it relates each input to exactly one output. Just like this picture that you're seeing here, this function is relating each circle to exactly one ring. However, in this picture, as you can see, blue circle is being related to two different rings, or just like the red one is being related to two different rings. Therefore, this is not a function. Cool. Now that we know what is the definition of a function in mathematics, we need to know how can we write it down on a paper. So we need to know the notation. So far, we know that we're going to put an input inside of a function and the result would equal to an output. Therefore, if we name the input to be x and name the output to be y, then we have the function of x equals y. Or in a short form, we just write f of x equals y. And this is the form that you're going to see from now on in your textbook or further in this lesson. Now, just know that all possible inputs is called domain and all possible outputs is called range. We're going to talk about these two concepts in other videos and go in details. But just here to be familiar with the terms that I'm going to use, just know that. Now let's practice together and see how can we translate a note into mathematical form of it. Let's say we have this note that we have a function that receives x as an input, add it to 3, and then give us y as an output. Therefore, if I want to translate these English words to mathematical notation, I would write the function f of x equals x plus 3. Also, I would like you to know that I am allowed to write it as y equal x plus 3. These two are completely the same, but just with different looks, with different notations. Therefore, you may see f of x equals something or y equals something for the functions in your textbook or later in this video. Now that we know how to translate English words to mathematical notation, let's have an example together. Let's consider the function that we just talked about, f of x equal x plus 3. And let's say that our domain, remember, all of the possible values that we can have for input. Let's say it is 1, 2, apple, 4, triangle. So, in order to see how this function works, we just need to put each of these elements in our domain instead of the input x in our function and see what will be the result. That's it. Therefore, first we will put 1. F of 1 would be 1 plus 3. So instead of x, I'm going to put 1, which will give me 4 as a result. Or if I want to use 2, it will be f of 2 equals 2 plus 3, which is 5. If it's an apple, I can put f of 3 is apple plus 3, and so on. Now let's see how we can graph a function in order to visualize it and see it. Well, let's continue with the function that we were talking about, f of x equal x plus 3. We should start giving values to x and see what would be the corresponding values to that x, which is y. So let's start with -2. If I put -2 instead of x in this function, it will be -2 plus 3, and the result is 1. If I put -1 in this function, it will be -1 plus 3, which results in 2, and so on. So, as you see, I am seeing some ordered pair of x and y. -2, 1, -1, 2, 0, 3, 1, 4, and 2, 5. Here you can see the red dots are the point that we found. In order to graph your function, in this case, you just need to connect all these points with a straight line. And this straight line, which is green, would be the function that we were talking about. We have different form of functions like linear functions, quadratic functions, cubic functions, or trigonometric functions. And there are lots of other functions out there that you will see in the future. So we said that we can plot a function and see it on the coordinate plane. But is everything we see on the coordinate plane a function? No. But then how can we recognize a function by just looking at it on the coordinate plane? The response is using the vertical line test. Now, let's see what is a vertical line test. Simply draw a vertical line through any part of the graph, and then if the vertical line touches the graph in more than one place, then it is not a function. And if the vertical line touches the graph in only one place every time, then it is a function. Follow this yellow vertical line in each of these coordinate planes. As you see, it's touching each of the curves in only one point, which represent that all of these are showing us a function. However, this graph, which is for y squared equal x, is not showing a function. Well, as an example, if we look at the point x equal 4, we will see that there are two different values for y at this point, -2 and 2. And you can see also in the formula that if I put x equal 4, I can have both -2 to the power 2 is 4 and 2 to the power 2 is 4. Therefore, this graph does not pass the vertical line test and it is not a function. Now is your turn. As an exercise, just evaluate these three graphs using the vertical line test and see if they're a function or not a function.